Kia ora and welcome to video 14 in our series Agile Algebra. This video here is a really short one. The problem is quite a neat one, very short. Find the largest A such that this equation is true. So of course there's some obvious values of A that don't work, like A can't be negative. Log base 10 if a negative number doesn't exist or it's not real. I used conic sections to solve this problem, so maybe think about how this links to your understanding of conics. But yeah, like always, give it a go, and we'll see you on the flip side for the solutions. Okay, first up, notice that the question doesn't mention anything about B, just finding the largest value of A. So to get our head around the question, if we just try different values of A and see what happens, so if I go like, for example, can A be equal to 10? Now pick 10 because the logs are base 10 there and it's an easy one to substitute. So if A is equal to 10, then the equation would become 4 log base 10 of 10 squared plus log base 10 of B all squared equals 1. Log base 10 of 10 is 1, so I get 4 plus something squared equals 1. Now that is only going to work if the log base 10 of B part is an imaginary number. And we, I guess, assume in here that A and B are real numbers because at this level of the curriculum, we don't know how to take the logs of complex numbers. So A can't be 10, so we need to go smaller than that. And it turns out the answer to the problem is A is equal to the square root of 10. And the reason for that is if we substitute in root 10 into this expression, or 10 to the half, we're going to get 4 multiplied by log base 10 of 10 to the half. Those cancel and we're left with a half. Squared is a quarter. 4 times a quarter is 1, so we've got 1 plus something squared equals 1. Now, of course, it's possible that this something here is just 0. We need to choose an appropriate B value for that to work. And of course, B is equal to 1 will do that. So that's the largest value of A possible. Now let's just have a look at the graph of this thing just to help us understand it a bit better. And we're not expected to be able to graph this I guess know what the shape of the graph looks like. We could make y the subject of this equation and then graph it using our graphics calculator. That's possible. But of course with Desmos we can just type it in as an implicit equation and there we go. The only thing is that I've used x instead of A and y instead of B so that it graphs it for us. And the question said the largest value of A. We can see there that is this position here, and the square root of 10 is a number just a little bit bigger than 3. So graphically, that makes sense. We could even use calculus to find that value because we would differentiate this equation, which isn't as easy as it looks because log base 10 doesn't differentiate nicely, unlike the natural log, if you know that. The natural log has a nice derivative. But we would be then looking for where the tangent is vertical. Having said that, I do know what the graph of this looks like. So what I've done is I've replaced the log base 10 of A part and the log base 10 of B part. I've made a substitution, replaced them with x and y. And then what I'm looking for is the biggest value of x, because if I graph 4x squared plus y squared equals 1, it's an ellipse. I can rewrite this as x squared divided by a half all squared, and y squared all over 1 squared equals 1. And for those of you who have done conics, you'll know that this number here is the radius in the x direction, and this number here is the radius in the y direction. So we can see that on the graph. It goes up to 1 and down to -1 in the y direction, and it goes across to a half and down to negative a half, and it's centered at the origin. If we want to shift that graph to be not centered at the origin, we would need some brackets around the x's and the y's. Okay, so this question is finding the biggest value of A biggest value of A? Well, a log base 10 graph, if we were to graph that, y equals log base 10 of A, where that's A and that's Y, the biggest value of A, say it's here, for example, let's say this is A max, that is going to also generate the biggest value of log base 10 of A. It'll be the Y max. The reason for that is it's an increasing function. So if we pick a slightly bigger value of A, it will have a slightly bigger value of Y. So the biggest value of A is the same location as the biggest Y. So log base 10 of A, if we want to find the biggest value of A, we're finding the biggest value of log base 10 of A, which, not to be confused, I'm calling that X. And on the graph there, we've got that X is equal to a half. That's the biggest value of X on the ellipse. So if we set that maximum X value, log base 10 of A, to equal the X value of a half, and then we take 10 to the power on both sides of that expression, we get A is equal to 10 to the half, or the square root of 10. So that is the max value of A. Maybe think about this question and what the minimum value of A would be, and don't get tripped up by it, because of course the original equation needs to be defined, and so that graph there isn't going to give you the right answer if you're thinking negative 0.5.